Okay, so we have a salmon colored formula sheet out. Doesn't have much on it, but that's because those are the only formulas you're going to need. Obviously a calculator today. And then let's look at our review and also a lot of things on worksheet 8. So starting with your first section, I believe there's 5 sections on here. Does that seem right? 1, 2, 3, 4, 5. Yes, so 5 new possible 5s coming your way in the gradebook. Arithmetic sequences. And if you look at worksheet 8B, which I think she put them up here, yep. 8B, look at numbers 1, A, and C in particular. So they use U notation sometimes for sequences. Don't be alarmed. That's not the same thing. Well, it is the same thing as A sub n notation, but sometimes your book utilizes U instead of A. So this clue right here states U sub 3 equals 8. Translate that for me. What does that mean? The third term is 8. And then the common difference is 2. So find the first 5 terms of the sequence. Well, you got to back up a little bit, right? If you're at the third term and you're 8. If you back up in this formula, you'd have to like add 2, right? You do the opposite. So this guy used to be a 10 and this guy used to be a 12. So 12, 10, 8... I can subtract 2, 7, 6. Hello, 6, 4. 1, 2, 3, 4, 5. Now, we didn't actually use the formula there, and that's okay. That's called conceptualizing the formula, and it works just great on a question like that. Look at the part C here. It says find the 30th term in the sequence. So at this point, if you would like to utilize the general formula for arithmetic, you can. It says take your first term, which we just found out was a 12. And then common difference of -2. And then because we want the 30th term, let's just go ahead and cut out the middleman and let's plug a 30 in right here. So what does that come out to? I don't have my key in front of me. Can someone do that for me? -46 sounds lovely. So part B is not something that we're going to be skipping. We're going to just come back to it in a later date because this is just arithmetic sequences on this first section. So you should just be listing out sequences and finding some various terms and finding general formulas. All right, so we're still on worksheet 8B. This time we're looking at number 4. They're using A sub whatever notation this time. So this says the 10th term is -8 and the common difference is -0.8. Find the first term. So there's a few ways you guys can do this. For most people, the easiest way is just to set up -8 as the solution. And then I don't know the first term, but I was told that the common difference is subtracting 0.8. And then because this was, remember, the 10th term over here in the parentheses set, this means it's 10 minus 1. For some of you, you went, oh, that means I had 9 hops. I figured it out that way. You're absolutely right. You're going to do the same sort of math. Whatever this number is, you're going to subtract it over yonder. And what did we get here? Did you get, is it -0.8? Oh, weird. Would that make you nervous if that was a test question and every clue to it was something with an 8 in it? Yeah, that freaked me out too, man. All right, so that wasn't too bad. All right, so far so good. So now we are still in arithmetic land, but we have explicit and then recursive formula. Very much so like the question you guys just saw in your post-test. So this should be easy peasy lemon squeezy for you. We do need to figure out, however, what the common difference is. And yes, it is a fraction, so if you're freaked out about that, then just go back to how you find a common difference. You take the second term and you subtract the first term. So has anybody figured out the common difference here? I heard adding 5. Okay. Yes. So this is like adding 35 over 7, better known as 5. Very good. If you weren't sure, you just literally subtracted them. So our first term is given to you. So when I go to write the explicit formula, I am not going to bother simplifying this because my teacher's lazy like me. So 2/7, and then you guys just told me that you are adding 5 times n minus 1 as a quantity. Now recursively, there's two parts to the recursive formula. The first one is this weird general looking thing where you say you take the previous term. How do you write previous term in these sequences? If I'm using a, it's a sub n minus 1, and then tell me how I move from the next term to the next term. You adding 5. Very good. The other thing you're going to have to tell me though is where you start. So you're going to say if your first term is 2/7. So both parts of that have to be there for the recursive formula. Please don't bother simplifying the explicit formula. It wouldn't be worth your time. Alright, so that's going to be the arithmetic sequence. Writing explicit and recursive formulas, giving some random terms and figuring out the first term, and then giving some random clues and can you figure out the first few terms of the sequence. So now it's the same idea, but this time for geometric sequences. So on your formula for geometric, you're going to see, I'm sure there's something, probably called the geometric sequence formula. Does it look like this? I believe that's the notation we used on your formula card. So remember, geometric is where you're multiplying by a common ratio every time. So, oh, did I skip some extras back there? Let me go back. Oh, back here in arithmetic real quick, there's an extra problem. What is the common difference if I give you the first term and the 23rd term? So I would like you guys to try that one on your own. I did work it out in the key and it is posted, but I'll move the post closer to the top of your feed, okay? All right, moving along. So worksheet 8B, let's go back and look at worksheet 8B number 8. So here you have a sequence listed out. It's in the geometric section, so I'm here to assume it's geometric. And they want the explicit and eventually the recursive formula. So the first thing I'm going to need you to do is figure out the common ratio. Common ratios are a little harder to figure out, especially when they're fractions. So what you want to do is take two subsequent terms and divide the later one by the earlier one. So like for us, the common ratio would be -4/6, better known as -2/3. So that common ratio is going to come into play in both the explicit and the recursive. The explicit formula, it's nice and easy. You start with the first term, which is 6. And then in the parentheses, that's the common ratio you just found of -2/3 raised to the n minus 1 power. The recursive formula, again, starts with that weird general previous term thing. So a sub n minus 1. But for geometric, you're multiplying by the common ratio of -2/3. Now, as far as notation goes, I don't mind if that's exactly how you write it. I get what you're saying. Some of you like to make this a little prettier looking, like you'll put -2/3 as a coefficient of a sub n minus 1. That's totally fine. But one more thing you have to tell your reader is where to start your sequence. So if the first term started at a 6, so both parts are necessary for the recursive part. So still on worksheet 8, we have a geometric sequence. What is R if your first term is -20 and then I give you a random 8th term? So this is one of those, this is going to pretend to be our solution for now. Gross. And then it says the first term is -20. And then it's to the times r to the n minus 1 power. So because you were using the 8th term, you would start by saying it's the 8 minus 1 power, but if you're a normal human and called that 7, you're totally fine. So if I think about what I'm going to do algebraically to solve this, you're going to start by dividing by -20, which if you don't like fraction work, you can also think of that as multiplying by -1/20. I would encourage you guys to, because it will say exact answer on your test, so either a little math enter in your life, or maybe some cross-canceling here. Wouldn't this become a 1/4? So keep that in mind if you're ever in a jam on your calculator, because there's only so many like digits that'll go out before it gives up on math enter and it's like you're on your own, kid. So if that happens to you, you got to back up in your work a little bit and do some like by hand reduction. Keep it as fractions as you go along. Anywho, we're not done. What is this, by the way, as a fraction when you make that prettier? Yeah. Thank you, yeah. And then remember, this is r to the 7th power. So now algebraically speaking, if you have to undo the 7th power, you have to 7th root it. but we've decided that it's a little easier to raise it to the 1/7 power. Or not, I don't know, maybe it's not. Please tell me that comes out decent. I'm looking at the wrong... What question is this? Is this on your review?
Yes.
Oh, I'm like looking at worksheet 8 going, this is not the right... Okay. It does come out lovely. Look at that. -1/4. Aw, that's nice. Cool beans. Okay. So, do you guys want me to back up and do these two? I can. Find the first 5 terms of the sequence. Well, all right. They already gave you the first one, 9. And then to hop from term to term, you're supposed to multiply by 3/2. So if you just start taking 9 and multiplying by 3/2, that is totally 27/2. Right? And then, okay, is that 50? I'm going to get this wrong. 81, thank you. 81/4. And then is it 243/8? And then 729/16. So that was kind of gross. But the math is not that terrible, and you all have calculators, so I really don't feel bad about it. So same sequence. They would like the exact value of the 13th term. So I would just use our formula. So the 13th term would be starting at a 9, and then the common ratio was clearly a 3/2 raised to the 13 minus 1 power. Or some of you were going, oh, well, I'm going to make 12 hops. I'm just going to call that a 12. That's fine. Yes, ma'am. What'd I do wrong? Oh, for this one? Yeah, because when you math enter this one, it's like real nasty, isn't it? Yeah. So, yes. It's okay. Right, right. So here's how you could get around that. This is 3/2 to the 12th power, right? You keep the 9 off of it for a minute, and you write out the fraction for 3 to the 12th power and 2 to the 12th power as separate, like, pieces of the fraction. And then you multiply the numerator by a 9. That's how you would get it by hand. How passionate am I about that? How about this? I very much count on the fact that on your test tomorrow, math enter will be your savior. You'll be okay. Okay? Got it? Yeah. I think I even did this on my key. What a trooper I am. Like if you multiplied 3 to the 12th power, you got 531,441, and this is 4096. And then if you just sneak this 9 up in the numerator, you get something. You get 4,7,8,2,9,6,9 over 4,096 with a smiley face. You talk a big game, but I know you're going to pull that one into a fraction. I do think so. I guess. All right, so number 4, this is on your review. You have a random 6 term they gave you. They gave you the common ratio. They want the first term. So this is a good case of using your formula. So this is the solution right now. I don't know the first term. You guys can go back to calling it a sub 1 if it bothers you that they called it u sub 1, but it really doesn't matter. And then your common ratio is 4. But what are we putting up here in the power, guys? Remember the random term they gave you was the 6th term? So yes, you can call it 6 minus 1, or you could be a human and call it 5. So whatever 4 to the 5th power is, divide that baby over. And you should get 1 over 5,000. All right. So now we're back to the idea of it being an arithmetic sequence, but this time we're going to have you sum them together. So we're going to call them arithmetic series. So you do have some formulas for arithmetic series, but you know I'm like a huge fan of sum of the sequence. Like it's my jam. So I don't mind which way you guys approach it, but if you could just kind of shoot me a note as you're doing your work, if you did sum of the sequence, maybe you could write down what you did a little bit, so that way if something's going wrong, I can figure it out. So they want me to look at, let's go back to that worksheet. Let's look at number 1, part B. So we're back to this weird Remember how we kind of like already solved this one out? Find the exact sum of the first 12 terms of the sequence. And if you remember from our work a couple problems ago, we figured out at some point in our lives, oh, they're using you, my bad. We figured out from our work that the general formula was, wasn't it 12 for our first term? Minus 2 times n minus 1. So that's the general formula. Your sum of the your summation for arithmetic series formula that they give you on the formula card, they only give you one of them, remember. And it's a nice one. It says it's n over 2 times a sub 1 plus a sub n. So what would you have to find in order to use that formula? Like you have the first term, but you don't have the 12th term yet. So if you wanted to use this formula, you sure could. You would do 12 over 2. And then the first term was a 12. Oh, I hate when they... Oh, that's annoying. Okay, so 12 shows up as the first term as well. And then if someone could work this out to the 12th term for me. What's 12 minus 2 times 11? I don't know. I'm not doing that today. It's Monday. It's something negative. Oh, yeah, I just want to know what the 12th term is. Because if someone wants to use this formula, they need the ending term. So what's 12 minus 2 times 11? Okay. Oh, I could have done that in my head. I didn't have any perseverance. Negative 10. Oh, I probably still could have done that in my head. My bad. Okay, so that would be fine to use that formula, but you guys probably can tell from my key, like, I don't like these formulas. So for me, I wrote sum, sequence. The formula comes next, so you'd have to write 12 minus 2. Depending on what mode you're in, it might say n if you're in sequence mode. It might say x if you're in function mode. So if you're in sequence mode, you will literally have an n. Doesn't matter though, because the next thing you type is the variable key, and then from 1 to 12. And what'd you get? 12? Oh, I hate that. Why would they do that? I didn't make this worksheet. Someone else did. It wouldn't be Hofbauer. She's too angelic to do that to you. Somebody else did it. Come on, y'all know you're paranoid about that. Why would she give me a problem with a bunch of 12s in it? She's just asking me to second guess myself, right? Alright, so we're still on worksheet 8. I think, yes. So find 3 arithmetic means between 22 and 16. Now notice the order in which they said those. 22 is your first term. And then there's going to be 3 blanks in between 22 and 16. But be careful, guys. This is arithmetic. How many times are you adding this common difference to get from 22 to 16? You added this common difference 4 times. So keep that in mind. The number of blanks does not equal the number of hops you've done. You got to get to that last one still. So we're going to set up 22 and then plus 4 times the mystery common difference got us to 16. And then we do a little solving. Yeah. So I'm getting negative 3/2. Cool. You can call it negative 1.5, that's fine. And then it says to find the 3 arithmetic means. So they want you to fill in, like, what are these numbers? So you're going to, quote, add negative 3/2 or subtract 1.5 each time. So that would be like a 20.5 and a 19 and a 17.5. And then I just kind of double check that that worked out. So yes, one more 1.5 down would get me to 16. So same sort of thing will show up on your test. And then there's a nice little application of the arithmetic sum. So the number of seats in a theater from front to back is given by that sequence. So I can tell that they're subtracting some seats every row. They're removing how many seats, by the way? Yeah, they're taking away 4 every time. There's 8 rows in the theater. How many seats in total? So this is a sum question. You can either use that sum formula where you have to find the last term in order to figure it out, or frankly, guys, you're halfway there. You could just find the next 4 rows and then add everything up together. But you know me. I love sum of the sequence. So first term was 50, and then you guys told me we're subtracting 4 every time. And then the first 8 rows. And what'd you get? 288. Cool beans. So this test is a little lengthy. And, you know, what we mentioned about you guys just finding all 8 rows and then adding them all up, while that technique doesn't feel like it takes that long, I think some of you who take that weird approach on every single question are going to run out of time if you start doing that. So you got to come up with some shortcuts, okay? So now, same idea, but this time it's going to be a geometric sum. And the test goes in this exact order. So you can rest assured that as you're looking through the test and you start with arithmetic sequences, like that's all that you're going to encounter in that section. So we tried to get really, really nice with you on this last test where they're not all mixed together, because I could imagine that would get confusing. So worksheet 8B again, numbers 2, 6, and 13. Let's start looking at those. So find the geometric sequence where the 4th term is 450 and the common ratio is 2/5. Find the first 4 terms, the 8th term, and then go ahead and sum up all the terms up to 8. Well, sure, why not? Okay, so the first couple questions here are actually not from the series section. They're just kind of the sequence itself, but that's okay. So the 4th term is 450. You got to figure out how to back up in this, so you can either conceptualize this or you could go ahead and use your formula itself. So think about this, guys. If you move forward by multiplying by 2/5, how would you move backwards in the sequence? You could divide by 2/5, better known as multiplying by 5/2 to go backwards. So go backwards, go backwards, go backwards. I'm going to steal my question answers because I don't remember this. What?
If you want to start with the first one.
Okay, so a fraction. I'm going to go 28,125 over 4. Sorry, I know. I'm so exact today, man. I think, no, I'm not going to claim I did this in my head. That's a lie. I was going to say, maybe I did this in my head. No, I did not. The 8th term, however, I don't really feel like going forward in this out to the 8th term. Let's just find the 8th term. So if you, now that you know the first term, you could just start with the first term, like the general explicit formula. That's what a lot of kids like to do. We'll talk about another option in a minute. Now remember, this time you're going forward in the sequence, so go back to using r as 2/5. And then 8th term would be to the 8 minus 1 power, better known as to the 7th power. Yes, ma'am?
So like this one, does it have to be a fraction?
Well, technically speaking, if you wrote those decimals down, those are exact because they're truncated. Like, you don't have to round them off. When you guys get those horrendous decimals that are like, 8 decimals out, you don't really know if they're truncating or not. Your calculator just stops with the pixels. So, the 8th term here, where is it at? Can't read. What number are we on? 2. Oh, 11.52, or you can write 288 over 25. And then finding the sum of the first 8 terms. I believe you have a formula for geometric series. Remember, that's the one I hate. That's the one where you got to be like really careful with your parentheses. So if I was you, I would not use that one. Let's just use sum of the sequence. I know, I'm very biased about this sequence formula. So, I know most of you have decimals going on here. That's fine. I am really cool with fractions today, apparently. Make sure you have your common ratio in parentheses, and also make sure that the n minus 1 power is also in parentheses, because remember it's doing horizontal script on your calculator. So comma n, comma 1, comma 8. This is a good example of, I really wouldn't want to write out all 8 terms on that sequence. They're kind of horrendous. So some of the sequence, I think, is where it's at. Do you guys want me to go through using that other formula, though? I can. I just really don't like it. It's just very easy for kids to mess up, so I don't like to use it. All right, so we're still on worksheet 8. This time we're looking at number 6. There's 2 geometric means in between 5 and 53.24. So remember, geometric means this time you are multiplying by a common ratio, but how many times did you multiply by that common ratio to get from there to there? Yeah, 3 times. So you did r to the 3rd power. So you start with a 5, you multiplied it by r to the 3rd power, and then you ended up at 53.24. So now we solve. Now it's important at this step, if this comes out a little funky, which I'm sure it does, don't round anything off. Okay? Don't truncate any decimals and round. Because whatever you have here, what is this, by the way? Yes, that. So I'm just going to write this. Because my next step is I'm going to raise it to the reciprocal power. So what power am I raising this to? The 1/3. I know you guys have a cube root feature on your calculator. You're welcome to use it. I just don't think it's really the right way to go. And this comes out nice, doesn't it? Like 11/5, doesn't it? 11/5, doesn't it? Yeah. 11/5, yes. Come on, y'all. Humor me. Or an irrational number. Right? No, there's other irrational numbers out there. Hello, square root of 2. Come on. Alright. Oh, I love this question. Because it's about viruses. My whole family's sick right now. All of them. You guys are lucky I'm here today. I was supposed to be home with a sick child. But I said, no, PreCalc needs me. So I left her with Grandma. Like a good mom. Alright, so virus reproduces at a rate of 8% per hour. There were 40 cells initially. How many will there be after 12 hours? So this is where everyone starts panicking because they're like, wait, is it like what we used to do or is it like this new stuff? And the answer is it's both. But if you stop and think about what initially means, to me, initially means the 0th term. So like, I'm going to call this the 0th term. If you decided to call it the first term, then we're going to have a little bit of a different setup, but our final answer is going to be the same. I suggest on the story problems to go back to your like root nature of how we do these problems back in Algebra 2. Call it the 0th term. So after 12 hours, and we're reproducing at a rate of 8% per hour. Okay, so we start with 40 cells. That's the initial, right? If you're increasing 8%, how do you write that as a... Yeah, 1.08. Very good. So 100% plus 8%, 1.08. And this is where the problem comes in. Because you guys are like, wait, it's to the n-1 power. Remember that formula? I'm going to kind of put an aside down here for you. This formula right here, this explicit formula, is contingent that you are starting at the first term. So these ones match. Like you can technically start this formula at any term. Like if I started with the 8th term, I would just put 8 here. So the idea of us starting at the 0th term means what do we put up in the exponent now? I'm just going to put 12. Yeah, a lot of kids put 12 minus 1 because they're just so used to putting 12 minus 1, minus 1, minus 1. But if you're starting at the 0th term, if you're calling that the initial term, which we are here, you got to call it just 12. So that's a little confusing. Okay? So what does this come out to? And this is... I don't know. Decimal would probably make sense here. We're counting virus cells or something weird like that. It's like 101. Here we go. It's real life. You don't need to... I mean, who cares? Virus cells. You got 1, you got 1,000,000. So come on. Right? Isn't that how biology works? You guys... What? I feel like maybe... Alright, so now we have our, please tell me this is our last section. Is this our last section? This is where you say, no, Bruzo, we have another. No, this is it. Okay. So, I mean, it's got miscellaneous in it. This is like, anything could be here. But the idea is you're going to see some things that basically just didn't fit in the other categories. So, if you look back at Worksheet 8, let's look at number 3. I want you to sum this series. So take a wild guess how I'm going to do this. That's right, children, sum of the sequence. So I love doing sigma notation ones on sum of the sequence because as long as it's not recursive, they already gave me the formula, so I'm ready to go. Sum, sequence, and then type in your formula. Be careful how you're typing this, though. This is 2 times n plus 1. You can just say divide by 5 like this. You don't have to use extra parentheses because it's just dividing by a singular number there. Comma, n, comma, and then you want to start at the first term and go up to the 15th term. So something fabulous comes out, I'm sure of it. Is it 54? Wait, what? It's not 50?
I got 54. 270.
What? Okay, so make sure this is a divide by 5.
Oh, I did.
Oh, we're just trying to figure out what's wrong. We're pausing for effect. I'm holding my breath. What's up? It's 54. Okay, cool. Ah. Okay, so here, wow. That would be like a happy birthday present on a test. What do they want you to do? Just plug in 8. You guys had a similar question on your post-test last week. You did fantastic. Nice job. That page was really easy to grade, so thank you. I was really happy. I was like zipping through it. What'd you get when you plug in an 8? Here and here. Oh, are you waiting for my answer? Well, I wrote down a fraction. 39 over 64 is what I got. All right, cool. All right, so this is a question I'm a little concerned about just because we didn't have tons of it on our homework and some of you never looked at your homework. So let's talk about this. I want to determine whether the sequence will converge or diverge. Now, I think we showed you how to graph them during our lesson, but turns out graphing is not super awesome for sequences. Plus you have to have a formula. So it might be easier if you guys just kind of explore what's happening on the sequence. So talk to me about the nature of the sequence. How are they moving from term to term to term? They're subtracting 90. Okay. So would it be fair for me to say that this is an arithmetic sequence and they just keep subtracting 90 every time? So if you think about continuing this on forever and ever and ever, basically it's going to look like a line, right? It's just going to keep dropping down 90 every time. So is this going to converge or diverge, to use a vocab term? This is going to diverge because it doesn't converge to a singular value. There's no asymptote feature coming up here. It diverges off to negative infinity. It never stops. But let's talk about this next one. What type of sequence are you looking at here? This is geometric, and looks like there's a common ratio of 1/2. So they're going to keep multiplying each term by half, by half, by half, by half. And if you really wanted to, guys, you could write a formula. This is going to be an exponential decay graph, right? The base is 1/2, so it's going to decay off. I mean, you think about the numbers, it'll be like 1/2, 1/4, 1/8, 1/16, and so on and so on and so on. It's just going to keep getting smaller and smaller, but it is, to use a vocab word, converging. By the way, what value is it converging to? What asymptote is it approaching? 0. Very good. So that's the idea. That's a good intro into our next lesson, which is going to be limits, starting on Wednesday. Yay. Yay. No, not yay. You guys can skip that question, actually. That's a fun question. It's just, there's not one on your test like that, I don't think. All they want is a recursive formula. I feel like maybe we should practice this, actually, now that I look at it again. All right, recursive needs these two parts, right? Let me do the easy part. First term is, boom, 900. Pulled that right off the formula. Recursively, though, if you take the previous term, a sub n minus 1, how do you move to the next term? What's the common difference? Find it. Yeah, you're subtracting 25. So there's your recursive formula. So once you get used to the notation, I think those are actually really nice questions. All right, I skipped a lot of questions. Let's go back on those extra practice ones. You want to take an adventure? Oh, how about this guy? Arithmetic, geometric, or neither? Well, I think the easiest way to approach that is to maybe map out the first few terms I don't know how comfortable you guys are understanding the algebra behind the series notation. I heard some people whisper neither on this one. Yeah, I'm with you. This one's neither. Have you figured out what happens inside of the sigma for it to be a geometric? Well, no, let's go better. Arithmetic, because that was the one you guys had on your post-test. Yeah, it was like 3n plus something or minus something. Because if you think about this algebraically, if you continually... Huh? Yeah, it looks like a linear equation because there's this multiplying scalar factor of like, oh, I'm multiplying it by 3, but what you're really doing is you're adding 3 like continuously. So you're adding 3, you're adding another 3, you're adding 3, you're adding 3. So if you want to wrap your brain around it that way, that's fine. So to use your words, this one that they gave us is definitely not linear, it's quadratic. But it's like n squared, which kind of sounds like maybe it's a geometric thing, and then they have this weird like -2 thing. So if you mapped it out, and I think that's the safest way to do your question on your test. If you mapped it out by plugging in a 1, you get, let's see, 3 minus 2 is 1. If you plug in a 2, that's 12 minus 2, that's 10. If you plug in a 3, that's 27 minus 2, and that's 25. Like, clearly I can tell you it's not arithmetic, and it's not geometric either, because it's, yeah, that's not the same R, not the same common ratio. So that's a big neither. Same idea here, guys. While there is a pattern, we have to decide if it's arithmetic or geometric. So if you're not real good at looking for patterns and figuring out what the nature of them is, just think about how you would have figured, like, let's pretend it's arithmetic. So if you think it's arithmetic and you find the common difference by taking 2/5 minus 1/3, well, what is 2/5 minus 1/3? Y'all should be reaching for a calculator right now because none of you want to do fraction mental math. I see you. Okay, she's going to squint her eyes at it really hard now. Grrr. Is it 1/5? 1/15, thank you. Yes. Okay, pen, work. But does that work to move on? Like if you start at 2/5 and you add 1/15 to it, do you come back to a 4/7? No, you don't. So it's not arithmetic, so never mind on that. And then I say, well, maybe it's geometric. What's 2/5 divided by 1/3? 6/5, right? So if I continue forward, 2/5 times 6/5 is not 4/7. So no to that. So that's a quick neither. Well, that's curious. She gave me 2 neithers on my review. Oh, dang it. All right. So I can do this. I can do this. The numerators have their own little pattern going on, and the denominators have their own little pattern going on. Have you noticed what the pattern is for the numerators? Multiplying it by 2, so that's a big old 16 next. And then have you figured out the pattern in the denominators? Yes, you're adding 2 to be official. Some of you went odds. So yeah, 11. Potato at that point. So it's not that there isn't a pattern. It's just neither geometric or arithmetic. That's all. You're all packing up. Is that because the bell's about to ring? All right. Well, good luck, everybody.